In this video, we'll take a look at some of the problems from Chapter 9 that have traditionally given students trouble. Okay, so first we'll look at question number 4, and it says if the standard error of the mean is 10 for n equals 12, what is the standard error of the mean for n equals 22? So this is essentially an algebra problem. What stays the same is the standard deviation of the population. Okay, so that's what stays the same. So standard deviation stays the same. All right, we can find an answer using this formula. All right, so the standard error is equal to the standard deviation over the square root of n. All right, so let's plug in the information we have at the beginning of this question. So what this is saying is if the standard error of the mean is 10 for n equals 12, so notice I've substituted 12 for n here and 10 for standard deviation, I'm sorry, for standard error, then we can solve for the standard deviation. So just cross multiplying, that would be 10 times the square root of 12 is the standard deviation. Now, to find the standard error when n is equal to 22, we can use the same formula. So we now have what the standard deviation is, so we can substitute that value in here, and then we can substitute 22 in for n, and that'll give us the new standard error. So the standard error is going to be equal to 10 times the square root of 12 divided by the square root of 22. And I think you should be able to find that with your calculator. All right. Okay, now I'd like to take a look at question number 8. All right, so this one is particularly tricky. So we have a normal distribution has a mean of 20 and a standard deviation of 10. Two scores are sampled randomly from the distribution. All right, so you hear that and you think, oh, well, that sounds like an n equals 2 sampling distribution. Not so fast, because the two scores are going to be sampled randomly from the distribution, and the second score is subtracted from the first. So here, you should be thinking, aha, difference between means, because we're subtracting the scores. Even though it's just a sample, that's what's going on, and it's just a single score, but it's still the same sort of thing. So what is the probability that the difference will be greater than 5? All right. Okay, so notice, this is one way to think about this. Imagine instead of having one distribution with a mean of 20 and a standard deviation of 10, what if you had two identical distributions? Wouldn't that give you the same answer? So they both have the same mean, they both have the standard deviation. And then the difference in means is 20 minus 20 is equal to 0, right? Now that's the way you have to approach this. So look at this as a difference between means, but with sample size of 1. In other words, taking 1 from each distribution. Okay, so maybe a visual aid will help. So this is what we're talking about here. So here we have the mean of 20 and the standard deviation of 10, right? Okay. So here we have one of these distributions. Imagine that there are two of them, identical from one another. So we're randomly going to take one from this distribution and subtract it from one taken from the other distribution. Now, if we happen to get a value over here from one of them and a value over here from the other one, then, we could get a pretty big difference, right? But we're more likely to get values close to the center. So usually the difference is going to be close to 0 because it's almost like taking 20 from 20. Okay, that's what we're actually dealing with here. Okay, so this is what we need to do. All right. What we need to generate a new distribution, right? That models the difference between means. So what we're going to need is a standard error. Now this is the formula for the standard error for the difference between means. So we have the variance of one of the distributions divided by the sample size plus the variance of the other distribution divided by the sample size, and then we take the square root of the whole thing. So standard deviation is 10, so the variance is 100. So what we're dealing with is we're dealing with the square root of 100 over 1 plus 100 over 1 is a square root of 200. All right, now when you take that square root, this is the value you get. Okay, so remember in the two distributions, they're identical to one another, so you're dealing with 20 minus 20, which is equal to 0. And what we want is we want the probability of values greater than 5, because that's what this question is asking for. Okay, so let's model this. All right. And, I've got my trusty calculator here, so I'm just going to go ahead and find the square root of 200 here, so we don't have any rounding error. Okay, so we can take that whole thing and hit Control Copy, go to our normal distribution. So that's the standard error, right? So we're going to put that in here. And we're making a sampling distribution of the difference between two means, which is 0 for this one. All right, now what we want is the probability of values above 5. All right, there it is. And there's the probability. So 0.3618 is the answer. Or if you rounded it off to 3 decimals, it would be 0.362. Okay. All right, so let's see here. All right, so using the normal calculator, you get 0.362. All right, let's take a quick look at question 18. So 18 is one of these true-false questions. Now remember, when you're working through these exercises, anytime you get something with an answer that's false, I want you to go back to the question and say, how could I change this to make it true? Okay, so the sampling distribution of R is equal to 0.8 becomes normal as n increases. Okay, this is false. This is the sampling distribution for that. So as you approach R equals 8, it gets really, really skewed. So no, there's in fact this would never be true. So as n gets smaller, maybe it gets a little more normal, but there's really no way to make this true. So I guess you could say the sampling distribution of R equals 8 does not become normal as n increases. Okay, let's see what else we have here. So it's still skewed no matter what. Let's see. Okay, I'll let you read over the rest of that if you want later. Okay. All right, so let's take a look at question 14. So in this one, so we have a city where 70% of the people prefer candidate A. Suppose 30 people from this city were sampled, so that's the sample size. What is the mean of the sampling distribution? What is the standard error of the proportion? So P here, what this is the 70%. And then what is the probability that 80% or more of this sample will prefer candidate A? Okay, so that's a parameter, all right. Here we have, a sample size. This is going to be, think of this as like a sample, and we want to know how likely that is. Okay, so for a proportion, the first two of these are pretty easy for you, I'm sure. So the mean is just 0.7. It's the same, all right? And then for standard error, this is the formula we use. So it's the proportion, pi, times 1 minus pi over n. So it'd be 0.7 times 0.3 divided by 30. That should give you about 0.08. Okay. Now, question C. So this kind of lulls you into a sense of security that, oh, I guess I'm supposed to use the normal approximation to work this problem. But no, you shouldn't. Always, so you need to recognize this as a binomial problem. All right. So always when you see proportions like this, you should be thinking that's a binomial. We've got a fixed rate of success. Every time we take one of these people, you can think of the 30 people as 30 trials, and you ask that person, which candidate do you prefer? The average rate of those 30 people saying candidate A should be 70%. All right. So we take this sample of 30 and we get 80%. Well, it's a little different than what we're expecting, but not that different. Okay, so recognize it as a binomial problem. Now, in this instance, you may remember we also had that rule of thumb, like when is it safe to use a normal approximation? This is one of those instances where this actually fails the rule of thumb. Because if you take n 30 times 1 minus p, remember two things have to be true. I guess I used pi in previous videos, but 1 minus pi has to, n times 1 minus pi has to be greater than 10, and n times pi has to be greater than 10. In this case, 1 minus pi is 0.3 times 30 is actually 9, which is less than 10. So what that's going to tell us is the binomial approach is going to give us a pretty different answer than using the normal approximation. Okay. All right, we're going to work this both ways because you have to know how to do it both ways. But unless I tell you or somebody else tells you you've got to use the normal approximation, then you should automatically use the binomial approach. All right, this is very important. I guarantee you I'm going to trap you with this, so you got to pay close attention to this. And recognize this as a binomial problem, and you should know, unless you're told otherwise in the question, use a binomial approach to the problem. Okay, so let's first try the binomial approach. All right, so if we have 80% is what we're seeing here, okay, so 0.8 times 30 is 24. Okay, so those are the, we want to know how likely is it to get 24 or more, because that's what this is asking. What is the probability that 80% or more of this sample will prefer candidate A? All right, so let's set this up with the binomial calculator and do that first. All right, so, whoops, wrong calculators. Okay, here we go, binomial calculator. All right, so we have 30 trials, right? Okay, now remember pi here, this is the parameter. So in the population, it's 0.7 or 70%. So there's the distribution. It kind of looks normal. It's close, but a little bit different. I guess that side looks like it's a little higher than this side, so not that normal. All right, and we want to know the probability of getting 80% or more. So out of 30, 80% is 24. You can see 24 right there, I think it is. So we've got to get above 23 because we want 24 to be an option. You see it's still red? Okay, so you hit recalculate. So here's the probability. So the probability of getting 24 or more people preferring candidate A is about 0.160 if you rounded it off. Okay, so notice you'd round all that up. All right, now let's try this with the normal approach and see what we get there, because it's going to be a little different. Okay, let's see, go back here. All right, let me see where we were on this slide. Okay, so for this, what we're going to need is we're going to need a standard error. We've got a mean, and then we're going to have to figure out the probability of getting 0.8 or more, okay, in a normal distribution. All right, so to avoid a rounding error, since I've got my calculator open here, I'm just going to go ahead and calculate this really quick. So what we want is the square root of 0.7, right, times 1 minus pi, which is 0.3, and then divided by n, our sample size, 30. Okay, you hit equal. So there it is. Now I had rounded it off earlier. Let's go ahead and copy that. Oh, to avoid a rounding error, you actually want to use a naked decimal. So we'll leave that 0 there. Hit Control Copy. All right. Now let's go back over here to the normal distribution. All right. So in the population, the mean is 0.7 or 70%, right? And we just found out what the standard error is. So I'm going to hold the Control key down and hit V to paste that number in there. And what we want is the probability of getting 0.8, right? 80% or more. Okay. All right, so here's the answer. As you can see, that's quite different. So for the other, using the binomial approach, our answer was, I think, was it 0.16? So this is like 5% off. I mean, that's, pretty far off. And so using the normal approach here gives us a very different answer. All right, so you may have noticed if you were looking at, Lane's guide to this. Let's see, this is number 14 here in his guide. He talks about this partial credit and stuff. So that's, again, using the binomial approach is the better answer. And as we saw, this is actually quite a bit off, all right, compared to that. Okay, he mentions something here called the correction for continuity. We're actually going to see that in the next PowerPoint or in the next chapter where we talk about estimation. Okay, so I hope that this helps you guys solve the other problems. I read through all these other questions here. In the past, students haven't really asked about any of these other ones. They're not that different from the questions that we have in the PowerPoint as examples in the PowerPoint. Remember, anytime you run into one of these and you can't figure out or you're not really sure what to do, in Lane's book, let's just take a look at this again. If you go to the chapter you're working on and go to the exercises here, so let's say you're having problems with number 5, for example. See, he's got this little relevant section. Use this like a hint. You can click on that, and you'll see at the top, difference between means. You're like, oh, aha, I'm supposed to be using this, and you can kind of really quickly review. There's like the formula for the standard error and things like that. So you can kind of quickly review how to work a problem like that. And then go back, and I think you can just hit the back button and go back and, try that question again. So you sort of use the book and the guide together. Always use these, relevant section tabs to help you find stuff. All right, so with that, I will end this video.